Hello and welcome back to my YouTube channel Electrical Hub. Here we are going to continue with the same topic, the efficiency of the motor. There are some parts which have been left, so we will continue those parts in the efficiency of the motor part 2. The topics we are going to discuss here are: what is energy efficient motor? What are the benefits of using energy efficient motor? Thirdly, how to reduce the losses of the motor? Fourth, technical aspects of energy efficient motor. And finally, effect of voltage unbalance on the efficiency of the motor. Here, you will come to know a lot of information about the energy management. So, I would like to request you to kindly subscribe my channel, like the video, and share it to your friends. I would also like to request you to kindly press the bell icon so that whenever we will share a video, notification will reach to you. Thank you. Energy efficient motors are the one with the special design to minimize intrinsic losses. How the intrinsic losses can be reduced? It can be reduced by using lower loss silicon steel, a longer core to increase the active material, thicker wires to increase the cross-sectional area, thinner lamination, smaller air gap between the stator and the rotor, copper instead of aluminum bars in the rotor, superior bearing, and a smaller fan. Benefits of energy efficient motors. So, what are the benefits of the energy efficient motor? Energy efficient motors will benefit with the energy saving of 3 to 4%. According to the BIS standard, in between 75% to 100% of load, there will be no loss in the efficiency. So, there will be an opportunity to vary the speed of the motor according to the need without compromise with the efficiency. We already have discussed about the losses of the motor in our previous video. I will share the link in the description box if you want to see that video again, or if you have not seen the video, you can go directly to that video. No, but here we will discuss how we can reduce those losses of the motor. First is the iron loss. Use of thinner gauge, lower loss core steel reduces eddy current loss. Means longer core reduces the loss by reducing the flux densities. Second is the stator loss. Stator or I square loss can be minimized by using large conductors and increasing the cross-sectional area of the winding, which result to the reduction of the resistance. Thus, I square R loss are reduced. Rotor losses by using large conductor bars of larger cross-sectional area lowers the resistance and flow of current. So, if the motor is designed for the energy efficiency, then the fan would also get smaller, and thus the friction and the windage loss due to the fan and the bearing will also reduce. Since we are using the optimum design for energy efficient motor, stay loss will also be minimized, but according to the IEC standard, we will consider it as 0.5% only. I have already discussed about the stray losses in my previous video. So, if you want to see or know about the stray losses, you can go back to the previous video and watch it. Now, let us discuss what are the technical aspects of energy efficient motor which benefit a motor in the long run. First is the longer life. Energy efficient motors last longer. Why? Because its operating temperature is lower compared to the standard motor. And in general, every 10 degrees centigrade drop in temperature of the operating temperature of the motor will increase the life of the motor by 2 times. It will also increase the maintenance and the greasing period. So it will affect economically both in the life and in the maintenance. Service factor. Generally, energy efficient motors works at 1.15 service factor at 85% of the load. Electrical power problem. This is a problem of the quality of the power, and the quality of the power get affected due to the voltage, frequency, and harmonics. Voltage. Due to the unbalance in the voltage, there will be an increase in the operating temperature of the motor. Due to the increase in the operating temperature of the motor, there will be a reduction in the life of the motor because every 10 degrees centigrade rise in the operating temperature of the motor will reduce the life of the motor by half. Number 2, frequency, and number 3, harmonics. Both are interrelated. Due to the fifth and seventh harmonics, the frequency of the sine waves get distorted, and thus a distorted waveform is received, which reduces the efficiency and the life of the motor. Speed control. As we know from the previous video that slip of the induction motor is equal to ns minus nr by ns. So, lower the slip, the speed of the motor will be close to the synchronous speed. So, lower the slip, higher will be the efficiency. But with a lower slip, the speed of the motor also increases. So while we are purchasing energy efficient motor, we should take in notice that what was the previous speed of the motor and what is the present speed of the motor, because the variation in the speed may affect the operation of the motor. We should also be aware of the torque. The torque of the energy efficient motor are lower compared to the standard motor. As we have discussed about the power quality, so according to the BIS standard, plus minus 6% of the voltage and plus minus 3% of the frequency is acceptable. Beyond this, it affects the efficiency of the motor. So, as we know, the voltage imbalance have a detrimental effect on the life and the efficiency. Voltage unbalance calculation. So, voltage unbalance calculation is done according to the NEMA, National Electrical Manufacturer Association of USA. I will show you that according to the standard of National Electrical Manufacturer Association of USA, how the standard deviation of the voltage is calculated. Now we will calculate the voltage unbalance percentage according to the NEMA, National Electrical Manufacturer Association of USA. So according to the NEMA, voltage unbalance is equal to maximum deviation from the mean of VAB, VVC and VCA divided by mean of VAB, VVC and VCA. So VAB is equal to 420 volt, VAC is equal to 440 volt and VVC is equal to 430 volt. For example, so what will be the mean of this? Summation of all divided by 3, which is equal to 430 volt. So voltage unbalance is equal to maximum deviation from the mean of VAB, VBC and VCA. So for the maximum deviation, we will take a value which will be greater after subtracting from the mean. So it is 430 minus 420 is equal to 10 divided by the mean of VAB, VCA and VVC, which is equal to 2.32 percentage. Here we will calculate the temperature rise of the motor due to the unbalance in the voltage. The additional temperature rise of the motor is equal to 2 into square of percentage of voltage imbalance, which is equal to 10.76 degree rise. As we know that for every 10 degrees centigrade rise in temperature, the life of the motor reduces to half. So, see here, even with the 2.32 percentage variation in the voltage, there is a reduction of the life of the motor by half. So, we should try to minimize the difference in the voltage each phase. Finally, I will provide you one convenient way to improve the efficiency of the motor. Generally, in the process industry, Some motors are overrated. They are running at 40 or 50% of their actual load. So, the motor which are operating at the 40% of the loading can be converted to the star mode. It will decrease the capacity of the motor by approximately 1 by third of its value, but it will help in reducing the magnetizing current, so the power factor and the efficiency of the motor will be improved. It will impact a lot of saving on the cost of power. So thank you for giving time, listening patiently. I would like to request you, please like, share, and subscribe my video, and also comment on my video for any of the question or anywhere you want a clarity. Then I will definitely reply to your comments. Thank you.